Hi everyone, it's Tara. Welcome to my little YouTube channel. So recently I got really into playing TryHackMe again. I hadn't really touched it for a couple of years and they came out with an attacking and defending AWS learning path, which I really wanted to try because AWS and cloud computing is what I'm really into and love to do. So I got back into TryHackMe so that I could play that. And now I'm just really enjoying playing through a bunch of different rooms. I'm really into it again. I think it's a lot of fun. And it's a good way to refresh yourself on things you already know about or learn new things as well, obviously. So I started playing some different rooms and I've been making little video walkthroughs just for fun and I've been really enjoying it. And then something amazing happened because not only was the attacking and defending AWS path right in my area of interest and I was really having fun with it, but just this week, a couple of days ago, I got like a marketing email from TryHackMe that they just dropped a totally new learning path for DevSecOps, which is also very relevant to what I do, a huge area of interest for me. And I couldn't believe it. I just always have like the most lucky timing. As soon as I get back into TryHackMe, it's like they're releasing content just like they made it for me. But anyway, of course, I have to play through some of these new DevSecOps rooms and see what they got here, see what it's all about. And I know people kind of have mixed feelings on the term DevSecOps. It's definitely like a buzzy term and some people roll their eyes at it. But the concepts of DevSecOps, as far as like CI/CD, secure deployment, code analysis, dependency, vulnerability scanning, all that kind of stuff is very interesting. And I hope that's the kind of stuff we're going to get to play around with in these DevSecOps rooms and maybe learn some new tools and everything like that. In this video, this is going to be a bit of like an introduction. So I'm going to go through the learning path quickly and just give an overview of what the different rooms are, what the path contains. I skimmed it a little bit, but haven't really looked in depth. And then I'm going to play through the first room, which I believe is just called Intro to DevSecOps or something like that. Oh no, this keeps happening to me. Ugh, I need to be like less enthusiastic because the thumbs up keeps triggering. But anyway, I believe that first room is called Intro to DevSecOps. So this video will mostly be a walkthrough of that. I promise I'll stop just gushing about things I haven't even seen yet. So without further preamble, let's check out the new DevSecOps learning path, and then we will play through the first room. Here's the announcement and everything. Our new DevSecOps learning path has landed. A new era has arrived. It's time to ditch tradition and shift to the left because DevSecOps is here to stay. This is like a very like banging announcement, lots of pizzazz. So we're delighted to share our new DevSecOps learning path, which shows you how to secure modern software development environments with hands-on learning around secure developments, CI/CD, which is continuous integration and continuous deployment, and automation security. And with a clear gap in training around DevSecOps and a lack of practical, hands-on, real-world learning on this topic, this path promises to be a game changer for those looking to advance in DevSecOps. Gosh, they are really building the hype. Without any more ado, let's go see what's going on in this new DevSecOps learning path. This is kind of similar to what I did in the attacking and defending AWS TryHackMe learning path little playlist of video walkthroughs I have. I'm going to do something similar here with this new DevSecOps learning path where I'm first going to just give a quick overview of the content because I haven't looked at it yet, want to see what all the learning path includes. And then in this video, I'll play through the first room and then make other videos as I play through hopefully the other rooms as well. So this is the DevSecOps learning path and it looks like it's going to focus on securing pipelines and introducing infrastructure as code and containerization security techniques. So infrastructure as code is like, that's like my number one tech obsession, love of my life. That's what I love to do is write infrastructure as code. So I'm really excited to see how they are featuring that in this learning path and what I can learn about IAC security. And we're going to learn the tools and best practices to ensure robust development processes and secure software deployment workflows. And and a minute ago, the TryHackMe learning materials reference shifting left. Hopefully my hand is left. I don't know how mirroring works in cameras. I'm like such a novice. But anyway, shifting left is something you always hear associated with DevSecOps, and shifting security left in the process means shifting security earlier in the software development process. So rather than finding out what's vulnerable in our applications once we've already deployed them and they're running them, and that's where we learn where our vulnerabilities are, how can we stop the vulnerabilities from ever even getting deployed in the first place or getting deployed to production in the first place? How can we use tools like, for example, code analysis and vulnerability scanning in our CI/CD pipelines to catch security risks and vulnerabilities as early as possible? That's what everyone is talking about. And those concepts aren't new, but those buzzwords around them, DevSecOps and shifting left, are certainly all the rage right now. And I buy into the hype just as much as anyone else. All right. Anyway, enough of the monologue for now. So, this is the new learning path, DevSecOps, and TryHackMe divides the learning paths into modules, which I personally really like because I can get like a nice little dopamine hit each time I finish one of them. And the first module is about secure software development. So, we're going to learn about the software development lifecycle, is what SDLC stands for, and how to integrate security into software development practices. So it looks like the first room is going to be introduction to DevSecOps, probably an overview, and more about shifting left. They promise we're going to talk about shifting left. And that's the room I'm going to play through in this video. And then SDLC, we're going to learn about. And then the third room will be SSDLC, which is secure software development lifecycle. Very good. And then the next module will be security of the pipeline. So that would be like a CI/CD pipeline. We're going to learn intro to pipeline automation, source code security. So that's typically almost as left as you can get is the source code. And then a room about CI/CD and build security. A lot of times, like a traditional CI/CD pipeline has different stages in it, different phases, and you would typically see like a source phase, a build phase, a test phase, and then a deployment phase. So the build phase looks like is what we're going to focus on here. And then, and that's just kind of like a simplification, but that's high level. And then next will be security in the pipeline. So we're going to have security of the pipeline and then security in the pipeline. That reminds me of a shared responsibility model in cloud computing where you have security of the cloud and security in the cloud. So this is going to be about making sure your pipeline itself is secure. And then security in the pipeline, I'm assuming, will probably be about how we use the pipeline to make our code more secure. Okay, security in the pipeline module looks like focuses on securing the code, encompassing SaaS, which is static, what is it again? Static application security testing, I think, and then dynamic, the D is dynamic, the S is static. So this would be dynamic application security testing, code analysis challenges, and dependency management for robust DevSecOps practices. That's awesome. And then we got this room called Mother's Secret, exploit flaws found in Mother's code to reveal its secrets. So that sounds like it's going to be pretty fun. And then container security. So we're going to have a room about just like containerization in general. If you're not familiar with containers, intro to Docker, intro to Kubernetes, which I know almost next to nothing about Kubernetes. I've just started to learn a little bit about it. So that will be really beneficial for me. We're going to learn about container vulnerabilities and then container hardening, how to make our containers more secure. That sounds like a really good module. And then lastly, the one I'm really enthusiastic about, infrastructure as code. So this will be great. This will be like my reward at the end of the learning path to get to do the IAC module. So we're going to have an introduction to infrastructure as code. We're going to learn about on-premises infrastructure as code and then cloud-based infrastructure as code, which is practically like what I spend 95% of my time doing. And I already know when I get to this module, the videos are just going to be insufferable because I'm going to want to talk about it all day. So feel free to skip them if you can't handle it. But anyway, I swear I don't work for TryHackMe. I'm just really enthusiastic, and I was really excited to see they rolled out this learning path. So I'm very excited to play through it, and let's get started with the first room. Okay, so here we are in the first room on the path, and this room is called Introduction to DevSecOps. Learn more about the story of DevSecOps software development models and shifting left. All right, so task 1 is the introduction. In this lab, you will get introduced to the different styles of software development and their evolution throughout the years. It's essential to understand how things have improved over the years and their impact on the security industry. So it seems like we're going to learn a little bit about the history of these things to contextualize why things are the way they are now. And let's see, learning objectives, the history behind software development practices and how they have evolved over the years, the importance of this field and concepts of what makes DevSecOps. And then I believe we can click here and see TryHackMe's definition. This is like a vocabulary feature. So DevSecOps fosters the same culture and principles as DevOps with the addition of security into the development process, ensuring security is integrated from an early stage. So DevOps was all about bringing together the development side, which is like software developers coding, traditional coding, like writing the applications, and then ops, which is like operations, system reliability engineers, system admins who keep the platforms and the systems running. DevOps was about breaking down the barriers between those two entities. And then DevSecOps is about bringing security into the fold and breaking down the barriers there even further to get security integrated throughout. DevSecOps learning path. This is the first room in a new DevSecOps learning path being developed. The new path will cover, I promise I won't just read it again, but let's see this but this is a bunch of the stuff we just saw in the path overview. And then this part is pretty interesting. So we've got attacking the pipeline, exploiting vulnerabilities in the pipeline, defending the pipeline, and then this part, which I'm so excited about, infrastructure as code. So we're going to cover cloud DevOps, secret management, exploiting Terraform. Very excited about that. Exploiting Vagrant and exploiting Docker. So for task one, that's just the introduction. We just read, we don't have a flag or any questions or anything, and we hit complete it to move on. Hi, I'm jumping back really quick because I meant to mention that this is one of the free rooms in TryHackMe. So you do not have to have the TryHackMe subscription to play through this room. If you come across this video and you want to play along, I'll make sure to put the link below so you can play this on TryHackMe even if you don't subscribe. All right. DevOps, A New Hope. I'm absolutely loving the drama in this room. The language is like top notch. And I believe this is a Star Wars reference. I shouldn't even try to say that, but I do think that is what it is. Since its inception, developer operations or DevOps has become a significant influence in modern software development, deployment, and operations. But where did the term come from? The story of DevOps. A long time ago, there were waterfalls in a galaxy far, far away. So that's definitely Star Wars, right? And waterfall model is this is the name given to how project management was approached back in the day. And then by back in the day, I guess they mean the 70s. The cycle constituted and relied on a hierarchy where every member had a specific responsibility. For example, system admins worked tirelessly to keep everything running smoothly and afloat. Developers build and add as many features as possible to the applications. And finally, QA, quality assurance engineers, test the system's functionality, ensuring everything works as expected. And if anything troubles the servers or something needs deployment, sysadmins jump on it. If it's a code problem, devs put out the fire. If there's anything to do with testing functionality and feedback, the QA team takes care of it. But what if there is a flaw, a bug, who fixes it? These situations lead to many blame games and passing the baton around that created friction. Things would get backlogged and the symbiosis between teams would not end up working anymore. As the number of customer expectations grew, features and new releases increased, responsibilities and tasks became an accumulative giant mess. Bugs and security flaws were backlogged. Plenty of these went unresolved and more releases scheduled, and everything just got worse and it wasn't scalable and it wasn't messy. And basically, they don't have a kind word to say about the waterfall method. So, fair enough. This is really describing a lot about like the team silo aspect of the waterfall methodology. But I've never worked in an environment that used waterfall software development or never been on a team or project that really did that. So the extent of my knowledge here is that in grad school, I took a class about software development methodologies where we learned about the waterfall methodology. So my knowledge isn't practical, it's just theoretical. But one thing that I would add here that I think is very distinct of the waterfall methodology is not just like the team silo part, but also the part where there's one phase and you do that entire phase and then you start the next phase only when that first phase is done. So first we do the analysis and get requirements. Then only after that do we start designing the software. Then only after the design is done and we have like a bunch of documents do we start actually making the software. Then only when the software is totally done, all the features are done, do we start testing the software. So it's all like big monolithic steps and they're all dependent on each other. That's really like what I associate with waterfall software development. So what was once the popular problem solving strategy and system became a root cause of ineffectiveness in flexibility and communication across teams. So doesn't seem like they're recommending waterfall model. And then came along agile. So now it's all about agile. And with the challenges teams were facing with waterfall, businesses started developing ways that allowed more flexibility and adaptability. So in the early 2000s, the agile methodology was coined. Soon, a manifesto was released, the Agile Manifesto, emphasizing 4 values for agile development. Those 4 values for agile development: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change versus following a plan. So that's probably a big one, more of that like adaptive, getting little pieces of feedback, implementing it versus waiting until the very end versus creating a plan at the beginning, following it all the way to the end without changing. And companies now value team collaboration and rely on self organizing teams, focusing on clients, and plenty of room for change and flexibility. So that all sounds pretty good. But something was still missing, and that was seems like DevOps, A New Hope. Okay, so it was Star Wars. And let's see, this is so cute. So we got like a little theme going on. In 2008, a conversation between Andrew Clay and Patrick DuBois led to something quite revolutionary. While discussing the drawbacks of Agile, DevOps was born. After an event in Belgium the following year called DevOps Days, DevOps was the next buzzword, it was the next hot thing, and the popularity increased. DevOps is quite different from the previous methodologies because it focuses on driving cultural change to increase efficiency. It does this by uniting the magic of all teams working on a project using integration and automation. With these ingredients, you get a cross integration across all departments, QA, plus sysadmins, plus developers. For example, ensuring developers can now be involved in deployment and sysadmins can now write scripts. QA can figure out how to fix flaws versus constantly testing for functionality. So the example I would imagine here, right, would be like imagine you're the software developer and you write the code for the application. And when you're done writing the code for your part, you hand it off to the ops team. And the ops team is responsible for figuring out what system to run that code on, maybe managing like the database that the code interacts with, all the different kind of like platform stuff, and making sure that the system is running the code reliably. And then you have the QA, the testers, they test your code once it's up and running. And the thing that DevOps is trying to avoid, right, is like, okay, the developers hand off their code, but they don't really know anything about the system that it runs on. And maybe the ops team is always annoyed with the developers team because they get the code and it's hard to make it run. And maybe the dev team is always annoyed with the testing team because the dev team doesn't understand the way they write their reports and they feel like there's not enough detail. Just all that little stuff that happens when the teams are doing their job completely separately, independently of each other, rather than having everybody working together from the beginning for the whole process. So, anyway, that's what I think of when I think of DevOps. By introducing automation and integration of systems, these engineers can now have the same visibility at all times and interact accordingly. We will dive more into how DevOps does this in the latter rooms as we will talk about pipelines, automation, and continuous integration and continuous delivery, which is CI CD. Now, I have to stop here. One time at my old job, me and a few of my friends got like in a very spirited discussion about what the CD actually stands for in CI CD. And there's three terms that you, I think, will hear kind of as the CD in CI/CD. So continuous delivery is one of them, which continuous delivery being like the delivery of the software to the end user. Continuous deployment is the other one. And then the third one that you hear a lot less frequently is continuous development. And in my opinion, they're all three accurate. The two that I really use would be continuous delivery and continuous deployment. But hey, if you're one of the people out there that likes to say continuous development, I support you as well. But don't be surprised if you hear those three terms used pretty much interchangeably. And I'm sure some people feel very passionate about what is the right one. So maybe someday they can have like a battle to the death over it or something. All right. So, why is DevOps important? DevOps builds a philosophy that emphasizes building trust and better liaising between developers and other teams. This helps the organization align projects to business requirements, increasing the impact and the value to the business as projects become more efficient and are prioritized accordingly. Changes rolled out are usually small and reversible. So I would say that's a pretty important thing to pull out. That would be very opposite to what I think would be the traditional waterfall model. And then changes are visible to all teams involved. This ensures better contribution and communication that helps with the pace and an increased competency when delivering work. So, in summary, thanks to the advent of DevOps, today's development infrastructure is fully automated and operates on a self service basis. Developers can provide resources to public clouds, and the public clouds would be like AWS, Microsoft Azure, GCP, without depending on IT to provision infrastructure, which in the past was a slowdown, led to weeks or months of delays. Continuous integration and deployment, so see, we're already using a different term there, processes automatically set up testing, staging, and production environments in the on cloud or on premises. They can be decommissioned, scaled, or reconfigured as needed. Infrastructure as code is widely used to deploy environments declaratively using tools like Terraform and Vagrant. And not technically all infrastructure as code tools are declarative, but most of them are. Most of the most popular ones are. And then organizations can now provision containerized workloads dynamically using automated adaptive processes. That doesn't all just sound wonderful. And then here's a note about what they mean by declarative. So the declarative approach requires that the users specify the end state of the infrastructure. For example, deploy these machines in a running state directly into an environment, automating the configuration choices throughout the workflow. The software builds it and releases it with no human interaction. And I would think of it like you're declaring your order, almost like you're declaring, I'm going to have this size machine and it's going to use this machine image, and we're going to have this kind of database. You're laying it all out. And then the infrastructure as code tool runs code to bring your vision into reality. The imperative procedural approach takes action to configure systems in a series of actionable steps. For example, you might declare to deploy a new version of the software and automate a series of steps to get a deployment ready state. You choose when to apply these changes at the end by adding a gate. So, an example of a gate could be a button to release changes, like a deploy changes button, after all the automated checks have passed. And then it can pass the deploy changes gate. In such a workflow, even a tiny problem could create a mess. Moreover, as a number of new releases increases, the whole matter may turn disastrous. Once again, living for the drama in this room. Things would surely go out of hand with an issue still unresolved and plenty of features scheduled to be released. Okay, so on that nice note, looks like we wrap up task 2 with some questions here. So, what methodology relies on self-organizing teams that focus on constructive collaboration? So we learned that was the agile methodology, I'm pretty sure. And then what methodology relies on automation and integration to drive cultural change and unite teams? I believe that would be DevOps, the word of the hour. What traditional approach to project management led to mistrust and poor communication between development teams? So, just on traditional approach alone, I think that's waterfall. And then, what does DevOps emphasize? Okay, well, we could probably answer that with a few different things. So, let's look at our little set of practices and tools and a cultural philosophy. Okay, I think that's it. So, what does DevOps emphasize? Let's scroll back up. Oh, I, all right. So, why is DevOps important? And then they have this part DevOps builds a philosophy that emphasizes building trust. So, I bet it's that. Let's try that. DevOps emphasizes building trust. Let's see if that's right. Okay, awesome. So, that is task 2 complete. And now we can move on to task 3. Task 3 is called the infinite loop. In the previous task, we learned about the different software development styles through the years and how these played a big part in the inception of DevOps. This task will introduce you to key concepts, tools, and how they all work together. So, how does DevOps work? DevOps is visualized as an infinite loop describing all the comprising phases. So, as opposed to the waterfall image, which you might remember was kind of like plan, design, and then actually write the code, and then test the code, and then release the code, and then maintain the code. It's not that. It's like a continual process that's just always going on. So, you have plan and code and build, test, release, deploy, operate, monitor, but the stages are a lot more fluid. They're always going on. You typically want to have small features that you're coding and you're building and testing those small features and you're releasing all the time so that you can get user feedback more quickly. And as you're operating and monitoring, you're learning more about what the next feature should be, how it should be built. It's just that infinite loop, like they said. Following the infinite loop of DevOps, let's expand on some DevOps tools and processes that we will look at as we follow this path and learn how those tools help an organization. Number 1, CI/CD. In the previous task, we mentioned CI/CD. CI/CD deals with the frequent merging of code and adding testing in an automated manner to perform checks as new code is pushed and merged. We can test code as we push and merge thanks to a new dynamic and routine in deployment, which takes the form of minor code changes systematically and routinely. All right, I'm not quite understanding that sentence, but the point is instead of waiting all the way till a feature or application is developed and then testing it with CI/CD, every time you make a little change to your code base, you can automate tests, you can build the code and test it. So every small change is vetted via automated pipeline rather than having to wait all the way till the end to test things. And things are being tested and integrated all the time as developers are working. Thanks to this change in dynamic, CI/CD helps detect bugs early and decreases the effort of maintaining modular code massively, which introduces reliable rollbacks of versions and code. So because you're doing smaller releases all the time, it's a lot easier to roll back to a stable version if needed without missing months of work or whatever. Infrastructure as code is a way to manage and provision infrastructure through code and automation. Thanks to this approach, we can reuse code used to deploy infrastructure. So, for example, cloud instances is the classic example. So, that's your servers running in the cloud, which helps inconsistent resource creation and management. Standard tools for IAC are Terraform, Vagrant, etc. I use Terraform quite a lot. My favorite infrastructure as code tool is the AWS CDK for deploying AWS applications. And this is a great topic you can get into with any infrastructure as code nerd, which tool they like best, what they think about the different tools. So, in addition to Terraform, CloudFormation is the big one. AWS CDK, I think, is the big one. Ansible, you hear about a lot. So, you can really start this is like a great conversation starter at a party. What infrastructure as code tool you like the best? And then we will use these tools further in the pathway as we experiment with IAC security. So, I think we're going to have a room about Terraform and a room about Vagrant, which I've never used Vagrant, so I don't know very much about it. And then configuration management. This is where the state of infrastructure is managed constantly and applying changes efficiently, making it more maintainable. So, thanks to this, a lot of time is saved and more visibility into how infrastructure is configured. You can use IAC for configuration management. All right. And number four, orchestration is the automation of workflows. It helps achieve stability, for example, by automating the planning of resources. We can have fast responses whenever there is a problem. For example, you can have health checks, and then when health checks are failed, we have automated response. So rather than waiting for a human to realize that something's not working or a server's not healthy, we're just checking all the time, and then we're have automation flows that kick into action when a health check fails. Monitoring focuses on collecting data about the performance and stability of services and infrastructure. This enables faster recovery and helps with cross team visibility, provides more data to analyze for better root cause analysis, and also generates an automated response, as mentioned earlier. So it's all about monitoring. Monitoring lets you be proactive, it gets everyone visibility into what's going on. Monitoring is critical. And then lastly, microservices. Microservice architectures break an application into many different small services. And this has some benefits over what's called like a monolith application. So, microservices lets you have more flexibility. They're typically thought to be more scalable. So, you kind of have these different building blocks. Rather than having to scale one huge application, you just have to make sure each of the building blocks is scaling appropriately. They're less complex in some ways. And then more options for choosing technology across the different microservices. So again, the different components of an application, like for example, like I'm thinking about a retail application, maybe you have like inventory, you have user management, you have user authentication, you have payment, and these are all managed as their own different services that know how to talk to each other, but a change to one shouldn't impact a change to the other. That's kind of like what microservices is all about in a poorly thought out example. And we will look at microservices in more detail in the DevSecOps pathway. Well, thank God for that because, like I said, my example wasn't very good. So, answer the questions below. What helps in adding tests in an automated manner and deals with the frequent merging of small code changes? I think that would be our friend CI CD, and it's physically impossible for me to write that in lowercase. So I'm going to write it in uppercase. What focuses on collecting data to analyze the performance and stability of services? I think this is monitoring. Yep. Okay. All right. And then what is a way to provision infrastructure through reusable and consistent pieces of code? All right. So that will be IAC or infrastructure as code that I cannot stop talking about. And then let's see. That's task 3 done. Awesome. So let's go right into task 4. Task 4 is called shifting left. Security can now be easily integrated because of the visibility and flexibility that DevOps introduces. You might have heard of the concept shifting left. I would say if you've been watching this video, you've heard of it. That should definitely be like a drinking game. Take a drink every time you hear shifting left in this learning path. Although don't actually really do that because I think we would probably die. On that note, this means that DevOps teams focus on instilling security from the earliest stages in the development lifecycle and introducing a more collaborative culture between development and security. Sometimes traditionally, security and development can kind of be thought of as having almost like an adversarial relationship because sometimes there's this idea that like development is trying to get things done and security is like the people just like constantly waving the finger and saying, you can't do that or you have to jump through all these hoops to do what you need to do. And one of the goals of DevSecOps is to improve that dynamic as well. Since security can now be introduced early, risks are reduced massively. In the past, you would find out about security flaws and bugs at very late stages, even in production. And this is part of what I'm getting at earlier. Imagine you've done all this work, you've coded your application, and then the security team comes back to you and is like, we need to change this, and this, like everything's wrong. Obviously, that's not a good experience for either party. This leads to stress, rollbacks, economic losses, chaos, and catastrophe everywhere you look. And integrating code analysis tools and automated tests earlier in the process can now identify these security flaws during early development, and that makes everything better for everyone. So, shifting left. In the past, security testing was implemented at the end of the development cycle. As the industry evolved and security functions were introduced, security teams would perform various analysis and security testing in the final stages of the lifecycle. Depending on the results of security testing, it would either permit the application to proceed for deployment into production or reject the application and pass it back to developers and tell them they had to remediate the flaws. This resulted in long days in development and, like I said, bad feeling between teams. Implementing security measures during all stages of the development lifecycle, then in parentheses, shifting left, just in case you didn't get that, shifting left, rather than at the end of the cycle, will ensure the software is designed with security best practices built in. By detecting security flaws earlier in development, remediation costs are lower and there will be no need to roll back changes because they'll be being addressed before it even gets to that point. This reduces costs, builds trust, and improves the security and quality of the product. Why are we shifting left? Back in the day, before Agile, developers would request infrastructure from IT and receive servers weeks or months later. Nowadays, the provisioning of infrastructure in the cloud is automated, so almost always, and this shift has improved development, productivity, and speed. However, the increased velocity can also spark security concerns and lead to flaws that go unnoticed. So, because we can move at a faster velocity because of the cloud, we can also introduce new flaws. And because we're moving faster, we're introducing more flaws and they're making it to production faster before someone catches them because the whole process is moving at a faster pace. So here is a nice graph. So we've got plan and design, develop and build, test, deploy and release, monitor, and analyze. And we're looking at and that's the x-axis, the different phases. And then on the y-axis, attention to quality. And in which of these phases is the attention to quality highest? And so in the traditional model, it's not until the later phases that we start paying attention to quality, and including in quality is security. And then the shift left model just means we're paying attention to quality a lot earlier so that we don't have to wait until we're almost done to catch the problems. All right. The shift left approach ensures the flaws are caught early. That's what it's all about. And in the fast paced environment, post development security reviews of new software versions or analysis of cloud infrastructure configurations, so that would probably be your infrastructure as code, become a bottleneck. So even when the problems are discovered, there is not enough time to remediate them before we need to release the next version or the next feature. To keep up with customer needs, they need a fast paced environment for scaling and growth. Security is at the risk of being left behind. Instilling security in the beginning and adapting security testing to become flexible and adapted to the development lifecycle increases the chance of catching things and addressing them promptly. And that is DevSecOps. With DevSecOps, security is introduced early in the development cycle, and this minimizes the risks massively. We integrate code analysis tools and automated tests earlier in the process, which can lead to better identification and elimination of security loopholes. And as the security gets to the deployment stage, everything is already working smoothly as anticipated, and we've already checked for all the things we can check for. So security is not an add-on. It's not like that last checkbox. It's a must-have right from the beginning, and we're avoiding a lot of the bottlenecks and the bad feelings. And then lastly, with a rise in the frequency of cyber threats and tightening regulations, adding security to DevOps is not a choice now, but indeed an obligation. So basically, it's like trust is worth it. All right. So here we have a couple questions. What term is used to describe accounting for security from the earliest stages? in the development lifestyle, I do declare I think the answer here is probably our favorite two words to use together, shift left. And then what is the development approach where security is introduced from the early stages of a development lifecycle until the final stages? And that is, I believe, DevSecOps. And once again, it's unnatural for me to write it without those capitalizations, those capital letters. That's task 4, and I do think that was all really good information, even though I poke fun a little bit at the shift left buzzword, but all good content. So let's move on to task 5. And task 5, we're back to our nice Star Wars theme. So we've got DevOps, security strikes back. DevSecOps is an approach that relies heavily on automation and platform design that integrates security as a shared responsibility. It's a culture driven development style and it normalizes security in day to day operations. We don't want security to be an add on, we just want it to be part of what we're doing every day as we develop. What is the value? DevSecOps brings down vulnerabilities, maximizes test coverage, and intensifies the automation of security frameworks. And a lot of DevSecOps tools that you will see are built with mappings to the popular cybersecurity framework. So that's another benefit, especially if you're trying to achieve compliance. DevSecOps tooling can help you do that. And this reduces risk massively. this reduces risk mass. This reduces risk mass. Oh my God. You guys, I just tried to say this word massively like probably 6 times. This reduces risk massively, assisting organizations in preventing brand reputation damage and economic losses due to security flaw incidents, making life easier for auditing and monitoring. How do we implement this efficiently? Culture is key. It does not work without open communication and trust. It only works with collective effort. DevSecOps should aim to bridge the security knowledge gaps between teams. For everyone to think and be accountable for security, they first need the tools and knowledge to drive the autonomy efficiently and confidently. All right. So basically, like we need to do it in a way that people will actually want to do it, not in a way that it's box checking and everyone's going to roll their eyes and pretend they're doing it, but they're not actually doing it. We want buy in and we want something that the developers and the ops teams will actually want to do, not something that makes their lives harder. And here's some of the challenges we see in DevSecOps security silos. It's common for many security teams to be left out of DevOps processes and portray security as a totally separate entity. They're their own thing, where only the specialized security people can maintain and lead security practices. This creates a silo around security and prevents engineers from understanding the necessity of security or applying security measures from the beginning. So you want everyone to feel empowered to implement security practices, be part of the security conversation. You don't want to have this air about, well, only the security team can do security things. That's not good. This model of the silo is not scalable, it's not flexible. Security should be a supportive function to help other teams scale and build without security teams being a blocker, without the security teams being the ones like, no, 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 you can't do that, making work harder. That's what DevSecOps is trying to avoid. But rather, we want a ramp to promote secure solutions and decisions. The best practice is to share these responsibilities across all team members instead of having a specialized security engineer. Lack of vision and prioritization is another challenge. We want to aim to create a culture where security and other essential application components treat security as a regular aspect of the application. Developers can then focus on development with confidence about the security instead of security departments playing police and blame game. So we want trust between the teams and we want security that promotes the autonomy of teams by establishing processes that instill security everywhere. Okay. And then lastly, another challenge is stringent processes. I would definitely say this is a big thing that contributes to that idea of security teams as a blocker. So every new experiment or piece of software must not go through a complicated process and verification against security compliances before being used by developers. So that's what we don't want. Procedures should be flexible to account for these scenarios where lower level tasks are treated differently and higher risk tasks and changes are targeted to go through that more stringent process. We don't want a culture where developers have to jump through a million hoops to like do a little experiment that's never going to see production. We want to have awareness that some things require more attention and process than others. So developers need environments to test new software without common security limitations. These environments are known as a sandbox. There's nothing I like better than a good sandbox. And they're isolated environments that are built for experimentation and they don't have access to customer data or production networks, things like that. All right, so What DevSecOps challenge can lead to a siloed culture? All right. So that is security silos. Let's see if that's the correct answer. Guess the answer was right there in the name. What DevSecOps challenge can affect not prioritizing the right tasks at the right times? Is it just going to go like right in order? Let's see. No. So that is not going to be the right answer. So maybe it's lack of visibility, perhaps it's lack of prioritization, since the question says, what challenge can affect not prioritizing? Let's see if that's right. Nope. All right. Security silo. So I'll try lack of visibility. Perhaps that's right. Okay. So lack of visibility can affect not prioritizing the right risks at the right times. And then lastly, what DevSecOps challenge stems from needlessly overcomplicated security processes? And that is stringent processes. So again, just good information, and we are cruising through. We're learning a lot. And then I think when we get to the later rooms in the path, I imagine we're going to be putting all this into practice. So that is task 5. And then we will move on to task 6. Task 6 is about DevSecOps culture. DevSecOps culture looks like we got 3 sections here: promote autonomy of teams. Whether it is a large organization or a startup in hypergrowth, the only way to not leave security behind is by promoting the autonomy of teams. This can be done by automating processes that fit seamlessly with the development pipeline until security tests become just another type of test, like your unit testing, smoke bombs, whatever kind of testing you're already doing in your pipeline. And leading by example and promoting education, like creating playbooks or run books to spot flaws and then fix them, understand the risk that these flaws cause, and build confidence in engineers to make secure decisions independently. The ratio of developers, platform engineers, infrastructure engineers, et cetera, all those other types of roles won't be the same as security engineers. And we must understand that they, meaning I think the security engineers, can't be in every conversation. So the security engineers on their own won't be enough to do it. You need to be able to get people in other roles involved. Security should act as a supporting function that focuses on building trust and creating as much overlap in knowledge between teams as possible. And then we have visibility and transparency. So these are like the components of a culture that promotes DevSecOps, I think. And so the first one was promoting the autonomy of different teams. And then now we have visibility and transparency. And this says for every tool being introduced or practiced, there needs to be a supporting process that provides visibility and promotes transparency to other teams. This means that if we want to build autonomy in groups, as mentioned earlier, they need to have visibility on the security state of the service that they own or maintain. For example, a dashboard visualizes the number of security flaws by the criticality of the service. This helps prioritize accordingly so tasks don't get lost in the backlog or noise and flaws can be tackled at the right time. So, we want to make sure that teams have visibility into the security status of the services that they own. Makes sense? How you want to measure security state depends on the company, but it could be that the number of high findings a service might or might not have determines if that particular service is in a good security state. And then again, you want people to have visibility into the different services, the kind of security flaws that are going on there, et cetera, get everyone on the same page. And transparency refers to introducing tools and practices that are accessible to the teams. For example, if you present a check before merging code, and the review doesn't pass and shows a message that says signature of possible code injection flaw detected, please remediate. So that would be the message of why the new commit, the new code isn't passing the security test. The developer or the engineer should have access to the tool that's flagging the message. Usually, these analysis tools that flag those alerts have a UI that specifies the line of code where this security flaw is. And the tools also include a definition and a remediation suggestion with steps to fix the flaw. So, in this example, a developer role should be created for that security tool so that the developer would have access to all the information about the security flaw, what the problem is, the instructions for fixing it. You don't want the developers to be gated out of the full functionality of the tool. And this promotes education and autonomy by extending transparency that traditionally was only accessible by the security teams. So even if you just were to give the developer some sort of read-only access to that tool so that they can see all the information, that would be a good step towards transparency, which would then be a good step towards your DevSecOps culture. And then lastly, last section here, account for flexibility thanks to understanding and empathy. As mentioned earlier, instilling security in DevOps processes with visibility and transparency is no easy task. There is a factor that can determine success, and that's the level of understanding and empathy. This means that the definition of risk for security teams is unequivocal, but for other teams, risk can be different and just as precise for them. This doesn't only apply to risk, but an umbrella of things. It ramifies into what teams prioritize, how they work, what they might think is important enough to drop everything and set aside a project, even if they're on a tight deadline to fix a bug, what rises to that level of importance. I think the empathy piece here is kind of about understanding security risks are very important. And then there are also other types of risks that are also very important to different types of teams. And so you want to be empathetic for those other types of risks that those other teams care about and understand that those risks are really important to them too. So there's no magic tool or process for everyone. It's essential to understand how developers and engineers work, what they know to be a risk, and what they prioritize. If you know their perspective, it's easier to build a process that finds common ground and has a higher chance to work versus adding another tool that creates just more noise and stress for everyone. The understanding builds perspective, which accounts for empathy for how other teams work, and builds a process that accounts for flexibility. This is needed because every situation might be different, deadlines might be different, and people's bandwidth can change over time. So, just in general, it's always good advice when you're trying to do anything, try and instill any sort of cultural change in an organization. You want to have empathy for the other teams, where they're coming from, what their priorities are, and start from there. And then lastly, as a DevSecOps engineer, suppose you took the time to understand how a team owns a service. In that case, that will have a security scanner added to its development process, worked and viewed priority. All right, if I'm honest, I don't understand how we got from that sentence to this one, but let's keep going. So it will be easier to get. So I think we're talking about a team, that owns a service. Okay. So the service is going to have a security scanner added to its development process. Let me start over. I got it now. As a DevSecOps engineer, suppose that you took the time to really understand how a certain team and that team owns a service that is about to get a security scanner added to its development process. You're going to really understand how that team works and how they view priority. It will be easier to get the team's buy in and then demonstrate value to them. For example, if it's a platform team and they own an internal service that's a core service, a risk to them that they would really care about would be a bug that disrupts that service. That's what they're going to be worried about. They're going to be less worried about a potential injection that lives behind a proxy because it's not like an external facing service. So you could tune the scanners or add a triaging process that tackles the questions that team is going to care about and ask themselves. And then this would in turn build trust with that team that owns the internal service versus giving them some noisy scanner that cries wolf and wastes their time and then makes them question why they're doing the security processes in the first place. And then looks like we have some cool examples here. Read about DevSecOps success stories. Let's see what's going on with this. So this takes an article, I think that is about three different success stories of how maybe it looks like three companies, Microsoft, Verizon, and Pokemon. Ooh, that's cool. Pokemon. Do people still play Pokemon Go? Is that over? Um, anyway, these three companies got DevSecOps cultures off the ground. So I'm not going to read it now, but that looks interesting and I'll probably save it to read later. And then here are our questions for task 6. First one is, how can you make security scalable so it's not left behind when startups face hypergrowth or in large corporations? All right. So if I had to think about it, I wonder if this is just going to once again go down the line. So the question was, how do we make it scalable so it's not left behind? And this looks like perhaps we are looking for this first section header. So that's promoting autonomy of teams. And then it says right here, whether it's in a large organization or a startup in hypergrowth, the way to not leave security behind is by promoting the autonomy of teams. So let's try that. Okay. Whoop, whoop. And my TryHackMe streak just increased by 1. So yay. And how can you support teams in understanding risk and educating on security flaws? All right. So that was transparency, right? And visibility. So visibility and transparency. Okay. And then what key factors to successfully instill security in the development process by accounting for flexibility? So that was, I think it was understanding and empathy, right? That's the one we just talked. Okay, great. So that is the 3 questions for task 6. And now we will move on to task 7, which looks like is more of a hands on exercise finally. So that will be a great way to wrap up this room. All right. So we are going to wrap up this room with an exercise. And it looks like that exercise is called fuel trouble. So I think we're still rocking our theme here. And we've got a static site to pull up. So I love the way that their static site goes right into split screen and it looks very cool. And I know for sure we're doing Star Wars because I see the font here. So we've got TryHackMe comics and let's see. So it looks like this is going to be about software development models. So we've got Sec 3PO. I'm not sure, but I'm just going to say Sec 3PO, a DevSecOps engineer, part Android. So that would probably be this, right? Because the androids are like robots. And then X-Fighter Dev and Chuba QA and then S2A2 have been assigned to discover minerals in nearby planets in the galaxy. Watto the bug is funding the mission by providing equipment and fuel to carry out the project. Okay, so I don't know which one's Watto. Yeah, maybe he's not in there. They are tasked to set a course and research these planets. Can you guess which software development model they have used in each case to achieve their mission? All right, so we opened the site and then we're going to figure out which approach was taken in each comic snippet. And here's some background. So the mission is to travel to the planet with the least amount of risk possible. We have enough fuel for 130 light years of travel. All right. And our models are waterfall, agile, and DevOps. So we're trying to figure out which approach they're using in each comic. I know I already said that. Now I'm saying it again. And let's see. Comic 1. Some tests have passed to go to testoing. Oh my God. Which was the initial decision by X Fighter Dev. Okay, so I'm assuming this is comic 1. And then it said, code is ready. Let's go to testoing. So that's X Fighter Dev's ready to go. And it's decided that this is the next planet to visit. Okay, so DevX says, so X Fighter Dev says, let's go. And then um, and then this guy, I think this is Chuba QA, says the tests have passed, so let's go. And then the systems have been deployed. So I think this is going to be waterfall software development because we see first the code is ready, then we have the next phase, they're doing tests, then we have the next phase, the systems have been deployed. So it's that very like linear waterfall, kind of one, then one, then one. So I'm going to draft waterfall as my answer for comic 1, but then let's see what comic 2 has. Comic 2 says, some tests indicated that it is a high risk to travel to test point. I'm so sorry. I don't know how you're supposed to be saying this. First, some tests passed for Naboo, but S2D2 has decided the course should be changed to Hoth. Okay, so less linear. It looks like they're like considering other options more iteratively. So the dev says everything is ready, built for testoing. And then Chuba QA says the test failed, but they pass if we go to Hackaboo. So let's do that instead. So they're just kind of changing the design, I guess, changing the course. And then the new version has been deployed, but this version is for, is this one another? Oh, yeah. But this version is for TryHackMe, the other planet. Um, and then I think this elephant guy is the bug because he just keeps asking how it's going to get paid for. So there's one in every crowd, I guess. But okay, so this is either going to be agile or DevOps, but I'm not quite sure which one yet. And then comic 3, the initial decision based on analysis by X-Fighter Dev is to travel to Hoth. Costs were questioned, and although Hoth is one of the closest, Sec 3PO has analyzed the trajectory and has set new parameters for the test. Cuba QA has concluded to change the orbit to Dagobah based on further tests. So I don't have much rhyme or reason to this, but the reason why I think comic 3 is DevOps is because of this part about um, the Sec 3PO has analyzed the trajectory and has set new parameters for the test. Oh, and I forgot to read the comic. So everything is built for TryHackMe, and then the bug saying who's going to pay for this event again, and now they're ejecting from the spaceship, and okay, and then they're doing more tests, whatever. But I think comic 3 is describing DevOps because of this part that says analyze the trajectory and set new parameters for the test. So I think because of those like configuration parameters being changed, uh, that makes me think it's DevOps. So I'm going to try that. And then what software development model did the team in Comic 2 follow? Well, the last one left is Agile, if I'm right. And I guess they're showing agility and flexibility. They're changing course midway through based on the tests, and I guess that was agile of them. I don't know. It's not that clear cut to me, but I'm going to try waterfall, agile, and then DevOps. So let's see if that is right. Okay, so we see finish, and then here's the flag. Okay, so here is the flag. Try hack me 1, 2, 3, and 1, 2, 3, like blast off, I think. So we should do waterfall. That is right. Agile, that is right. And then DevOps is number 3. And then we can submit the flag. And that wraps up the intro to DevSecOps room. I think our total shift left count ended around like 19. These rooms are always kind of tough because it's just a lot of reading, a lot of exposition. But the concepts that this goes over and the emphasis really has me excited for the later, more hands on room in the path. I think there's going to be a lot of good stuff ahead. So thank you for watching if you did watch this one. And I'm really excited to tackle the rest of the rooms in this DevSecOps learning path. So maybe I will see you in another room walkthrough soon.